Well, considering the graph, the sine wave graph you can see on the board there, we can detect the movement of the conductor loop at any moment or any point in time. When the conductor loop's in its vertical position, we'll start from that point there. We're going through 0 as the conductor loop starts to rotate in that direction to that point there, which represents on the graph, we'll go for a different colour, t divided by 4. In other words, it's pi divided by 2, which gives an angle of how many degrees? 90 degrees. Good. Make a note to that effect on your diagrams. As the conductor loop starts to rotate, and it continues to rotate to its vertical position once more, in the diagrams previously, that will be Wy. The induced EMF starts to fall to that point there. Well, that value there, you should already know by now, and it's represented by that symbol, which is pi. And the value of pi, therefore, Joe Creed, is how much? If Joe isn't there, Ben will do. Or Brad. 180 degrees. Will do. Or represented by t divided by 2. T representing time. Okay, let's just get rid of that, them two at the bottom. We'll continue the waveform in the bottom half of the diagram to that point there, as we did before, and we can determine the value of the EMF, or induced EMF more particularly, at that point there, because it is 3 times pi divided by 2. Well, as we're concerned with a circular motion or rotation of 360 degrees, that point there will represent 270 degrees. If we continue to rotate the conductor loop 1 complete revolutions, how many revolutions, Jack? Good, 1 complete revolution. We go up to that point there, to our starting position, and that's represented by an angular velocity of 360 degrees, or we could say it's 2 times pi radians, or angular velocity times time, which is radians. 2 times pi, angular velocity times time, which is in radians. We demonstrated that before on the circle that you drew earlier on. Okay, whilst you're drawing that, we did say before that if I asked any one of you to pick a point on that graph and determine the EMF induced into the conductor loop, you may all come up with different values and different points. And to plot that firstly, in the first instance, can be quite hard work. So to determine the induced EMF, to determine the what? Excellent. The induced EMF. Well, we need a simpler method of calculating how much EMF is induced into a conductor. If I can clear that board very, very quickly, I'll leave that diagram up just for a few seconds so you can take a look. We should arrive at a generic formula that represents how much EMF is induced into a conductor loop. Now, from the explanations earlier on in some of the other videos, you should recognize the formula very, very easily. for the induced EMF of a conductor loop. I'll give you a moment or two just to find it in your notes. And when you have done so, we'll have up, let's have up Jack Glenham to the board and write up the formula that you have for identifying the induced EMF into a conductor loop. If Jack isn't there, let's have up Daniel. Christian, we need to move on. Okay, Daniel should have identified that the formula that we used was E equals 2 times B L V sin volt. That was a formula that you identified earlier on. Or we could say in radians, that's in degrees, or in radians, I write radians in green, 2 times B L V angular velocity time sin. And I will swap that around very, very quickly now that we've identified it, because you should be aware that sin does become before angular velocity like so. Okay, make a note to that effect very, very quickly and we can move on. Okay, let's clear that. Let's see what else we've got. We've got some notes coming up. I'll read them out very, very quickly. If the coil is rotating at n revolutions per second, then it is rotating at 360 degrees times n degrees per second. Now, we did say that n refers to, Alex, what? Yes, okay, we are referring to the cycles per second, or the frequency, yeah, which n equals, yeah, or the number of cycles per second. So if the coil is rotating at n revolutions per second, then it is rotating at 360 degrees times n degrees per second. If the coil is rotating at n revolutions per second, then it is rotating at 360 times n degrees per second. Hope you can see that.